Glory, glory, hallelujah. Teacher hit me with a ruler. I cracked her in the bean with a frozen Jimmy Dean, and she ain't my teacher no more because she's dead.
All right, everybody, welcome to the 8-3 notes. Today we are going to factor. We're going to factor trinomials and we're going to solve. It's essentially the same thing we did with FOIL, just in the reverse direction. So you'll notice right here, you remember from factoring when we had x plus 3 times x plus 4, and we would do first times first, outer times outer, inner times inner, and last times last. That's what's going on here. And then we would combine our like terms in the middle and we would get an answer. What we're going to do now is we're going to use that same concept to work in the other direction. So factoring an equation like this, x squared plus bx plus c, if we look right here, this is the one you want to look at. The example is way easier to understand. Okay? We have x squared plus 6x plus 8. Well, I'm looking for two numbers that multiply to 8 and add to 6. And those two numbers are 2 and 4. And that's really all we're doing. Okay? We'll talk about how signs can make this different, but really, here's a table that some people like to make, but really, my suggestion is to go straight from the problem to the answer. And now, if you want to make a table or something off to the side, I think that's fine. But if you look at x squared plus 9x plus 20, I'm going to set up two parentheses right underneath it because the directions were to factor, and this is a quadratic. And I know that x times, sorry about that, yikes. I know that x times x is how I get x squared. Then I see a plus sign and a plus sign. Well, I need two numbers that multiply to positive 20 and add to positive 9. So I know it's going to be two positive numbers. And then I just start thinking, this part you're probably doing in your head. Well, 1 times 20 is 21, 2 times 10 is 12, 4 times 5, hey, that's 9. There's 4, there's 5, and we are all done. Okay? I'd like you to try to do these, and I'm going to walk you through both of them. But pause the video. Try to do 1A and 1B on your own. Go ahead and pause the video now. You're looking for set up two parentheses, and then you're just looking to go FOIL in the reverse direction. Pause the video now. All right, so hopefully you've tried them. We're going to check mine against yours. So we set up two parentheses right underneath it. That's the easiest way to do it. D times D is how I get D squared. And look, there's a little error in the book here. They have D and then they have X. So it doesn't matter which variable you picked. And then I need two numbers that multiply to positive 24 and add to 11, and those two numbers are 3 and 8. Now, if you have D plus 3 times D plus 8, that's the same thing, right? Because 2 times 3 equals 6, and 3 times 2 equals 6. Hopefully for the second one, for 1B, two numbers that multiply to, this one, to be honest, I would rearrange it. I think it's much easier to see when we put the variable first, when we put it in standard form. If you didn't, that's fine. But I got t times t, and then two numbers that multiply to 9 but add to 10, and that's just 9 and 1. Okay? The big deal with these problems is, 1, checking your work, and then 2, understanding how signs can come into play. In example 2, we have a positive but a negative. So the only way to get two numbers that multiply to a positive and add to a negative is if both numbers are negative. Okay? If both numbers are negative. And there's a calculator example right here. I'm going to show you how you can check your answer with a graph. We'll do that together in class. But let's take a look at, I'm going to help you do 2A. Yikes. I'm going to help you do 2A, and then you'll try 2B on your own. Again, I don't know why they put them in this order. I think it makes it more complicated, so I'm always going to rewrite it. So I have m squared minus 22m plus 21. And then I'm looking for two numbers that multiply to positive 21 but add to negative 22. Okay? Now, this is easy. This is m and m. They're both going to be negatives. Okay? And so my choices for 21, I could have negative 1 and negative 21. I could have negative 7, negative 3. I don't have that many choices. The 7 and 3 add to 10. 1 and 21 add to 22. So that's it. 1 and 21. And that's it. That's all I got. You pause the video here. You try to do 2B. Go ahead and pause the video now. All right, you've unpaused. Hopefully for 2B, you got W minus 4 times W minus 7. And again, the order doesn't matter. So now we have, again, just more changes with the signs. When the last term is the negative term, then those are probably the hardest ones because we're gonna have some pluses and some minuses in the answer, and we're not sure which is which. Okay. So here we end up with, we're trying to get x squared. We have x squared plus 2x minus 15. So we have an x and we have an x. Then one of them is going to be a plus and one of them is going to be a minus, and you have to find two numbers that multiply to negative 15 but add to 2. And what they show you here in the table is that it's positive 5 and negative 3. You know, the easiest thing you can do is just check. Just do FOIL and check. You know, here that's x squared, that's negative 3x, this is positive 5x, and this is negative 15. Our like terms right here in the middle add to 2x, which is what they were in the problem, so I know it's right. Okay. Here, same exact idea, except for now we have two negatives. Again, I'm just going to have one positive, one negative as part of my answer. The big deal is that I guess numbers that work, and then I check it. Okay. Guess and check. It's called that because, well, you got to do both. So if you could please go ahead and try 3A and 3B on your own. Go ahead and pause the video and try those now. All right, you've unpaused. Hopefully here you got y plus 16 and y minus 3. Hopefully over here you got y minus 6. Or sorry, y, that's an r. And r minus 4. Okay, if you didn't, try them again. If you still don't, make sure you make note of it, and in class we'll check and I'll show you exactly how I'm doing these. To solve equations, we're going to use that zero product property we talked about last time. So after I factor, I'm just going to set each factor equal to 0. So if you take a look at this example, we factor it and we get down to x minus 3 times x plus 9. Then same thing we did last class. X minus 3 equals 0, x plus 9 equals 0, and the roots, the word roots, zeros, solutions, x-intercepts, all the same thing. Okay, x equals 3 and x equals negative 9. Again, you can substitute those back in and make sure you got them right. Let's go ahead and pause the video here. I'm going to help you. One helpful hint, you can't do this unless it's equal to 0. So I'm going to change 4a for you. Z squared minus 3z minus 70 equals 0. 4b is ready for you. Go ahead and pause the video here and try to do those now. Pause the video, please. All right, so hopefully for 4a, when you factored it, you got z minus 10 times z plus 7, which means z equals 10 and negative 7. Then hopefully over here you got x, when you factored it, you got x plus 6 and x minus 3 equals 0. Sorry, I left off my equals 0, which means that x equals negative 6 and 3. Okay, so those are our answers for those two. Again, if you didn't get it, pause the video, try them again, see if you can find your mistake, and if you still can't get it, you're going to ask me about it in class. Real world problem, you know, this is just, we've been doing these guys. This is w times w plus 2 plus 4. We put them together, then we take it apart and factor it. The thing here is that you got to know, like, the negative answers aren't going to work when we're talking about width. You can't have negative lengths, okay? So go ahead and try number 5, the height of a parallelogram. I'll show you. These are useful sometimes for us to draw so we can get a better glimpse of what we're talking about. So the height of a parallelogram, let's draw a parallelogram. Beautiful. The height right here is 18 centimeters less than its base. The area for a parallelogram is base times height. So we don't know either. So if the height is 18 centimeters less than its base, this is the base. The height is b minus 18. The area is 175. So I'm going to do b times b minus 18 equals 175. Okay? Here's what I want for you. I want you to pause the video right here, and I want you to solve and tell me what the height is. Go ahead and pause the video now. All right, hopefully you worked out the problem and you got the height is 7 centimeters. Okay? Do me a favor, try those 11. Okay, we'll talk about these 11 in class. I'll answer any other questions you had about any examples. That's it for the notes. I will see you guys next time. Bye.